Hi, in this video we're going to do an introduction to dependency injection, and then we're going to create two projects that will demonstrate how it works. So first of all, let's talk about what dependency injection is and why you would care about it if you're a programmer. So dependency injection is a common programming technique that is used in projects that have lots of different modules. The idea is to make the modules that you create more independent of each other, less rigid. And so it's to make things better and more maintainable. So the three things that I can think of why you would want to use dependency injection is that your classes become more reusable. So if you're in a team and you have projects that are going to be adopted somewhere else, you can save a lot of money by reusing your project. They're more testable. So if you try to run a test against something that is very complex, it becomes very difficult. And of course, rigidity is something that is bad when it comes to reusability. I'll give you an example of what this all means so that way it doesn't sound so abstract. So let's take a look at two examples of a car. So the top one is your typical car that you would create in a class, in a course like a university. Let's make a car, let's say, and let's give it some wheels, maybe 4 wheels, maybe more. And then we'll have a motor. And so we instantiate these things inside the class. We say, let's create a new motor, and you just new it up. You create a new instance of it. So that is a has-is relationship, or has a relationship. Now, the code that you're going to see in the examples is going to look more like the reddish pink one below, where instead of saying, let's make a new list and make a new motor, we're going to put in the interface for a motor or an interface for a wheel inside of the type. Now it looks like a small difference, but when you put in an interface, it allows you to substitute different kinds of wheels. Let's say we had Goodyear tires or Firestone tires or off-road tires or racing slicks. These tires then become interchangeable on your car. And I guess the engine would be too, maybe not quite as easily swapped out in real life, but the idea is that we're going to have more swappable components, and this will be important when it comes to building things like data access or loggers or other types of items that are less tightly coupled to your application. So here's a simple rule. If you want to follow a dependency injection, a quote: when you're writing a definition of a new class, never instantiate anything inside of it. So unfortunately, most of the code examples that you see from me do exactly this. We instantiate things inside it. For instance, we say we need a new repository for the data. We just say equals new data repository, and away we go. So it's simple to code, but then it becomes less flexible in the future. So here's an example. So we have a method here, or a class called getInput. The first line there where it says get or data getter, and we got a new instance of it, there it is. That's the new instance of it. And we're going to try to avoid this when we use dependency injection. So let's remind ourselves of some principles called solid programming, S-O-L-I-D. So solid means S. Make your code to have a single purpose for each module. For example, this knife here can do 80 different things. We would rather have 80 different knives, and that way we don't have to carry around this massive switchblade. Now, a single responsibility would be, for example, if your game is to have a scorekeeping module, you don't make the module say, update the score, check for a game win, and print it to the screen. That's 3 different cases. We want to split that up. Another is to have a principle called open-closed. And the idea here is that if you have a module that you want to expand, you extend it, you don't go in and modify the original. And the idea is that when you're building an architect plan for a building, that you have it extensible. So that way you can just knock a wall out and add a new room rather than tearing the house down and rebuilding it. Another is the Liskov substitution, which is kind of a little more complex. And by the way, these you can watch all these principles on a longer explanation on a different video that I have. But a descendant class of something should not be something that would break the original. For example, if you have a car, you would not descend into a child to be a helicopter. You would want to design it rather to have a general vehicle and then make that the parent. Another is to have interface segregation. So, and we've all had an interface where we have these adaptable cables. They're very handy because you just need one cable, but they're also very awkward because you might have, in this case, 8 different ends to it. The last one here that we're talking about is called dependency inversion. It's one of the 5 solid principles of programming. And think of a Dremel. A Dremel is a tool that simply has a spinning axle, and you can attach things to it. You can make it into a drill, a sander, a grinder, a small saw. It does lots of different things. And the idea is that the drill bit is going to be interchangeable. And so that's the analogy that we're trying to do here with dependency injection. We have an interface, for example, give me data, and then the data can be different types of data. So the inversion of control is a principle that we're talking about here. So dependencies are injected. Injected means they were just passed in as a parameter rather than hard-coded in. And then we can take away that dependency. We want to do this because it makes the code maintainable, easily updated, and testable. So the object coupling is bound when you run the program through a configuration file, and the components then are linked together. So some examples that you would use this with, such as if you have a logging program, and we've done logging in the previous lessons. What happens if we didn't want to use the library called nlog? We wanted to use a different one. Well, dependency injection would allow you to change it out without modifying your original code. Business services and data access services are 2 other examples. And we're going to demonstrate a data access service. If you may recall in this course that we're teaching right now, the data access that we have has 2 different forms. We have one that connects to a database, a SQL database, and then we also created another data access for our products just straight from a text file that was very static. And so we're going to demonstrate how we can substitute one of those data sources for the other with a single line of code. So that fits right into the idea of having fake data versus real data. So if you want to do some testing on fake data, then you can, and real data when you need to. So there are 3 ways that you can use injections into code. One is called the constructor, the other is through a property, and the other is through a method parameter. So we're going to demonstrate with this first one here called a constructor. You can see the example of a constructor of a program here called test logging service controller, and it is asking for a parameter called service. Notice the type of the parameter doesn't say data service as its data type, it says iLogger, and so that means it's an interface. And so you can have 1 or more different types of services passed in here, and the configuration file, an external file, will determine which one of those things it'll be. Secondly, there's another syntax that you would do. It's called a implementation of a class property, and you can put in a square bracket and put the word dependency, and it'll work just fine. And the other is a method parameter, which is very similar. So we're going to demonstrate the first of these 3 examples. So the recipe to make this is to create a service first of all, and then it has an interface. So that means there's more than one version of your service. And then you have to make sure that those are both conforming to the plan that was in the interface. And then here's the configuration file, what it's going to look like. Literally, we're going to say we have a paired up association going on. For instance, if we have a logger called mylogger2, it is going to be paired with this interface called iLogger. And literally, we would just go in and change this line if we wanted to change the data source for our application. So 2 examples that we're going to code here. One, we're going to make a console app, which will take away all of the complexities of the web application, and we'll just make a simple game with heroes and weapons. And then we'll go back to our products application that we have done in previous tutorials, and we'll swap out the data source. So you can see how easy it is to change from test data to production data in a real class. Okay, so let's get started with coding of our first example. So the first thing I want to do is start up Visual Studio and create a new project. I'm going to select a console version, and let's call this thing video game dependency example. The first thing I'm going to do is create an interface for one of our game objects. Let's call it a weapon. So iWeapon is the object name. And you notice it's an interface. Also, let's give it a method. Let's say attack with me is what any weapon can do. Let's also define an interface for our characters in our game. We'll call them heroes. So the interface will be called iHero. And his action will have one thing. The hero can attack. Next, let's actually create a class, and we'll call this thing sword. So we will give the sword one property, and it will be a string. We'll call it sword name. So now let's go ahead and implement the iWeapon interface, because that's what it is. It's sword as a weapon. So when we choose iInterface as the thing that we're implementing, you'll get the red underline that says you must implement this method. And so we do. So attack with me then becomes something that we must program. It's part of the interface. And for this guy, let's just say the console right is our message, and we're going to say the sword name slices through the air, devastating all enemies. So put some kind of a string in here to let you know that you're using the sword. Now let's make a hero. So I'm going to right click and choose add item. I'm going to name my class as hero that only uses swords. And so we're going to program this one very statically. He will not have the ability to switch weapons. And the property that we'll give him is a name. So let's choose string and name for the property. So now I'm going to create a method called attack. And all it will do is print a message. But I'm going to make sure that I do it wrong. Let's say, quote, wrong. What I'm going to do is instantiate the sword inside of this method. And so we'll say, we'll do it wrong the first time. Later we'll demonstrate the dependency injection. So when you create a new sword or a new object inside of a class, that means that the class has now a strong dependency on its objects that it possesses. And so it cannot exist unless that sword also exists. And so that's what we're trying to demonstrate here. So the code to make this happen, we're going to instantiate a new sword here. So we'll say sword equals a new sword. And let's give the sword name Excalibur. And then we will console write out to say that this person prepares himself for the battle. And then we use the sword attack method, attack with me. So the demonstration here is that the sword now is instantiated inside of this attack method. So imagine now that this sword is no longer needed and the hero wants a gun. Sorry, you're stuck with a sword. We've coded it in. It's static. It's inflexible. So now let's go into the program CS. This is where the main action happens. And we will instantiate a new hero. We'll call him Hero 1, and he's of type hero that uses only swords. We'll give him a name called Ultraman, and then we will make him attack. And then finally we'll add a console read line, so that way we'll see the message before the console window closes. Let's run this and see what happens. So hopefully this does not shock you what the results are. We get a message that says Ultraman prepares himself for battle. Excalibur slices through the air, devastating all enemies. So far, this is pretty normal looking. We haven't done any dependency injection yet. We've just demonstrated that this sword and the hero are welded together in the code. You really cannot separate them anymore. Now let's make a new weapon. We'll call this thing a new class, and then the name will be Grenade. So Grenade will have a single property called name, and then let's implement the iWeapon interface since we can attack with it. We will then have to implement the method, and we will have the method called attack with me. So very similar to the sword, but now the method will just be slightly different in how the weapon works. So now for the print message for our attack, we'll say name sizzles for a moment and then explodes in a shower of deadly metal fragments. Now we're going to demonstrate a new hero that can use any weapon. So let's do a right click and choose a new class, and let's name this thing hero that can use any weapon. For his properties, let's give him a name, which is a string, and then the second property, we'll call this thing his type as iWeapon. So it's an interface, and we'll give the object or the property name as my weapon. So you can see right away now that this is no longer going to be fixed to a sword or a grenade. It could be either or because they're both of type iWeapon. So now let's turn this hero into something that implements the iHero interface. So we have to implement the methods, which is going to be attack. It appears that heroes can attack, and that's their only purpose. So let's put in a console write that says name prepares to attack, and then we'll take his weapon and use the method called attack with me. Next, let's create a new hero. We'll call him hero 2, and his type is going to be a hero that can use any weapon. And when we create him, we will instantiate him as his name will be Aragon, let's say. His weapon, of course, has to be a sword. So we will make my weapon to be equal a new sword, and let's call this sword Brissinger. Then we can make hero 2 do his attack routine, and let's put in a console write just to separate him from whatever comes next. Now the third hero that we're going to make is going to also use any kind of weapon. So his type is hero that can use any weapon, and we'll call him hero 3. For his instantiated values, let's give him the name of the Joker, which is kind of debatable whether he's a hero or not. But let's give him a new weapon. And since he is the type of hero that can use any weapon, we could put sword here, or we have another option now called the grenade, and we'll give his name the pineapple. So let's print out his messages, and let's run the program. So the application ran, and let's see what we got. So first of all, Ultraman uses his sword, and then Aragon also uses a sword, so they seem to be indistinguishable. But the second type of hero that can use any weapon can also have a grenade. And so you can see that the Joker now uses his grenade called the pineapple. And so we're just demonstrating here that the fact that an interface can be used to swap out the weapon of the hero. So this is going to go somewhere, I promise. This is going to show what dependency injection will work with in just a few minutes. Now let's carry this example a little bit further with dependencies. We're going to make a gun and bullets. So let's first of all define a type of bullet. So the bullet class will have two properties. We'll give it the string as a name, and then an integer as the amount of powder that the bullet contains. So grams of powder is a good name. Okay, now let's generate another weapon. So I'm going to create a new class, and this class will be called gun. The gun will have two properties. The first one will be a string, which is his name, not surprising, similar to the other weapons. And this one's going to be different though, because he is going to have another property of a type list, a list of bullets. And so the bullets can be loaded or unloaded. So we need to implement the iWeapon interface if we're going to make it a true weapon. The weapon interface says we are going to implement the method called attack. Now in this case, we're going to have a little bit different type of attack. We're going to check first to see if there are any bullets in the gun. So if the bullets counts is greater than 0, then we will fire a bullet. And firing a bullet means do a console write. It'll say the name of this weapon fires a round called, and then the bullets each have their own name. So we will call the name of the bullet, and now they will say the victim has a deadly hole in him. And then we'll do a console. We'll have to remove the bullet from the gun then, since it's been fired. And if there are no bullets, then we will have an else statement. And the else statement will say the gun has no bullets, nothing happens. And so take a second here to review all the code that we're writing here. This gun has two properties, a name and a list of bullets. And then the attack method will check to see if a bullet is in the gun and remove it when it is fired. So now let's go ahead and create an instance of this new hero. So he's going to be called Hero 4. He is of type that can use any weapon. So let's make his instance to say the name is G.I. Joe. He's going to have a new weapon, which is a gun. And the gun, we'll call it 6-shooter. And then we have to create a new list of bullets. So the bullet is list of bullets is a new list. And then we've got ourselves the task of defining all of those bullets. So the first bullet we'll call as Silver Slug, and he will have 10 grams of powder. Now I'm going to copy and paste these bullets so that way I have less typing to do. So the second bullet I will name as Lead Ball and give him some number of grams. The third one I'm going to call Rusty Nail and also update his grams of powder. And then the last is called the Hollow Point. All right, so now we've got a kind of a confusion of all of these parentheses and brackets. Let's see if we can fix some of these. So I'm not sure if I got the right number or not. Also look up at the list itself has to be using collections. Let's see if we make that. Oh my goodness, we've got lots of brackets here. Let's see, I probably need a semicolon after this one, and my code is reformatted. I believe that looks more like it, so I'm just going to line things up so that they look nice and more readable, and maybe do some indenting so that way it looks like one belongs to the other. Okay, so clean up your code so that it looks something like this here. We've got a new G.I. Joe. His 6-shooter gun has 4 bullets in it, and each of those bullets has a name. So pause if you need to check this out. Now let's go ahead and make him fire his gun. So I'm going to make G.I. Joe attack. So hero4.attack is the method. And since we're checking to see if he has lots of bullets in his gun, we should fire more than 4 times. So we'll copy and paste. Let's run this and see what kind of results come out. So sure enough, we have results for G.I. Joe as well. It tells us exactly which bullet was fired. So for instance, it says the first round is the silver slug, and the second one is lead ball, then rusty nail, then hollow point, and then finally it says the gun has no bullets. All right, let's get to the dependency injection part of our tutorial and see what all of this nonsense is supposed to demonstrate. So consider a minute here the 2 heroes that I've just created in this diagram. So hero 1 has a gun, hero 2 has a sword. Both of these are pointing to an eye weapon interface. And so if we were to change some configuration, we could tell the heroes now that instead of an eye weapon being a gun, it could turn into a grenade or something else. So to use this new dependency injection idea, we're going to go into the dependencies of our project itself. So right-click on the project and choose NuGet and manage extensions with NuGet. So we're going to browse for different things that we can add to our project, and I'm going to search for the word depend. And what I'm looking for is Microsoft Extensions Dependency Injection, and we'll choose the install method. So now we can close the project dependency managers. So now let's switch into the program.cs and scroll down to the bottom where we've been doing our different heroes. So what we're going to code next is like a configuration file. And so I'm going to put some comments in here to let you know that in ASP.NET, this kind of work happens not in program.cs, but in a config file. So we'll be doing that slightly different in the next example. So in this section here, we're going to create what's called a service collection. So service collections are what are considered a, quote, container. A container will be like a box that contains a list of all registered dependencies. So service collection is the class type. The instance is services, and we'll just create a new instance of it. So the next section down is going to associate what each weapon will be by default. So I'm going to use grenade, for example, as the default new weapon. To make that happen, I type in services.add transient. So transient means it's temporary. And I'm going to associate 2 things. So iWeapon, comma, and then the weapon type that all new weapons will be. So in this case, grenade. Following this pair of associations, I'm going to create a small function that will just generate a new grenade. So I'll say grenade arrow function equals new grenade, and the name I'm going to call by default is exploding pen. And it looks like I forgot to make the arrow actually an arrow, so let's fix that. Next, I'm going to define all of the heroes to be a hero that can use any kind of a weapon, and I'm going to name him Johnny by default. So we'll do services.add transient, and then the 2 different associations again. So hero is going to be associated with a weapon, or the hero that can use any type of weapon. And then we're going to have a little function that runs after this that will let us create an actual instance of it. So we'll say hero arrow function equals a new hero that can use any weapons. And his name will be called Johnny English by default. Now the catchy part is, what's his weapon going to be? So we are going to say my weapon is going to be equal to hero. It looks like I need to change it from hero 1 to the word hero. Hero .get services or get service, and then whatever weapon was already assigned. So this depends on the lines that were just defined before here. Then we need parentheses and a close bracket and a parentheses again and a semicolon. Wow, we got all those syntactical things going on. But when we're done here, we're going to say that all I heroes are going to become Johnny English. Now lastly, there's somewhat of a compile step or an assembly step that we're going to create that will define everything above and put it into one package. So it's called a ServiceProvider, and we'll name it as provider, and it's going to use the services dot function called build service provider. And so it will define all these associations in one package. Okay, finally we get to the end where we can implement this thing. So let's create a new object, and we're going to just say his type is var because it could be flexible. So his name is hero5. To get his definition, we're going to say, let's go to the provider object and say, get the service of whatever I hero currently is defined as. And then we're going to implement it. So we'll test it out with the hero5.attack method, and then put a right line, and then finally we're done. Okay, so all of that gives us some flexibility to say what hero5 is going to look like. Right now, he should show up as Johnny English. Let's run it and test and see what happens. Okay, so you can see all the 4 heroes were no changes, but then the last item down here at the bottom, we see Johnny English now is hero5, and he has an exploding pen, which is really a grenade. Now, all of this coding comes down to one advantage that we're going to demonstrate here. We're going to change out the weapon without actually changing any of the constructor. So let's comment out the current process that associates a weapon with a grenade. And now we're going to make a new item. So we'll copy and paste. So the new item is going to be of type sword. And the sword, let's call it as the name is the Sword of Gryffindor. Now you can see that there is a message that says there's a problem with this. Don't I have sword as the name? Let's check to see what the solutions are. Oh, it does say sword name is actually the property in your class. Okay, so sword name. Let's see what happens here. Now, so Johnny English should now have a sword in his hand instead of a grenade. And so now we look down at the last item. It says Johnny English appears to attack, and he does have a sword in his hand instead of the grenade. So we did a swap out using this configuration of the dependencies. All right, so now I'm going to see if we can trust Johnny English with a gun. So let's go to the dependency associations, and I'm going to copy and paste the definition for a gun and his 4 bullets, and I'm going to put them in where the sword definition was. So it looks like I have a few fix-ups here to do, but the type gun is now associated with I weapon, and so Johnny should have a gun in his hand. I'm going to run the application and see if it works. So it looks like I've got the application running, and 6-shooter is in Johnny English's hand, and he shoots, and there's a bullet hole in the victim. Now it only shot 1 bullet, so let's go back and see if we can make Johnny attack a few more times. So I'm going to copy and paste a few more attacks for Hero 5 and run it again. And this time we should see Johnny run out of bullets as he shoots. And sure enough, when we look at the output here, it says Johnny English prepares to attack, and his gun now has no more bullets in it. Okay, so let's see what we were supposed to learn from this. So we created this idea of a service collection, which means we're going to associate objects with a concept. So the concept is we are going to first of all think about the concept of an I weapon. And you can see that we copied and pasted several things. We had swords, grenades, and guns. And they could be swapped out for whatever I weapon was going to be defined as by one line of code. The second thing is we had a hero that was also swapped out. So we could have changed out Johnny English just as easily with this line. And so Hero 5 could be flexible. It could be Johnny English, it could be Batman, it could be anyone we want to define. Now, all of this code here is supposedly independent from the program. So instead of putting it in program CS like we have in this example, The next example that we're going to code will actually go into a config file in ASP.NET. And so the next example will be more realistic and will show us where you would use some data sources to be defined as dependency injected or not. So let's go to the next coding example right away. In this activity we had done in a previous tutorial, we have a list of products, and you can see that I have searched for soup, and all of the items that relate to soup show up. Now where we're going to do our code change is the actual data source. So all of these pictures and these products are coming from a SQL database. In a previous version of the tutorial, we created a hard-coded example, and all of the changes we're going to be able to set up right here in the controller area where we have the repository defined. So let's do a quick change to switch from a data source to another data source, and then we'll do dependency injection. So first of all, let's take a look at the data sources that are available to us. So I have a folder called Services, and you can see that there is something called an iProduct Data Service interface. And so the interface is a key point here. We have an interface that defines two different types of data. So the one that we've been using in recent tutorials is this one called the product DAO. And as you can see, it has all of the same actions as the interface, but we talk to the SQL database. The other is called a hard-coded data repository, and literally we just defined the objects in the code as strings. And so we could swap these things out using dependency injection. So now let's go in and make a change manually into our products controller. So I'm going to open up products controller CS, and we can see here on line 14 and the constructor that we're using the products DAO, which is the database, the SQL database. So I'm going to comment out that line which says define repository. I'm going to redefine it. So the type now is called hard-coded data repository, and we'll instantiate a new instance of that using the same name. Now you can see that there's an error down below that says the repository's types don't match anymore. So let's replace one with the other. And so now we have replaced repository with a different data source. So this is the manual process of changing our code. In just a moment, we'll use dependency injection to do this in a configuration file separate from the code, but the result will be the same. So when we run this, we should see different data. So we got the application up and running. I'm going to choose the products link, and this time we're not supposed to see soup, we're supposed to see the hard-coded values. And so sure enough, the first 5 values in the hard-coded were computer things, such as a mouse pad or a hard drive, and then these ridiculous names that came from another fake data source. But the data is different now because we have changed the data source. Now, instead of going in to code these manually, let's implement the dependency injection using something called the Unity framework. All right, so the next place we're going to look at is in the the startup CS file. And so in startup CS, this is where we can configure dependency injections. So I'm looking for the section here that says configure services. And we're going to just insert some new lines here and do our dependency associations. Now the line that we're going to include is going to be this, services dot add transient, and then the brackets. Now we're going to associate an interface type with a class type. So the iProducts service or data service is the type. Now we have to import that or use the services folder. So we'll do a little bit of a injection there, or a code include. And then we're going to tell it which one of the data services that we want to use. So in this case, the first example is hard-coded data repository. And so this one line then is where we would change our data service. Now let's go to the controller again, and we're going to comment out the property called hard-coded data service. Now we're going to make a new property. Its data type is going to be the interface. So iProduct data service interface. We'll still call it repository, and we'll have a get and set. Now, the constructor then needs to have some kind of a parameter passing in which type of data service we're using. So we'll put in the property of iProduct data service, and we'll call it data service as the name of the parameter. And now repository is going to be assigned to that. Now, this is going to take its cue from the config file that we just used in startup. Let's see if it actually runs. So I got the app up and running. Let's go ahead and click the products link, and hopefully we get some data. And sure enough, we have the same thing we did before. This comes from the hard-coded values. So we can see that because I remember the first 5 items were all computer parts, such as mouse pads, webcams, and so on. So it appears that the data service has been defined correctly as hard-coded. Now we're going to switch this with one line of code. Now to switch this, I go back to the startup file, or startup CS, and the line here where it says we're going to associate the iProduct data service with something, we can swap this out. So let's take out the hard-coded one, and the other was called DAO, wasn't it? So it was products DAO was the item I'm looking for. And now the program should change the data source, and I never have to come back and actually code anything anymore in the controller. So let's run this and see if the switch actually occurs. So the app is up and running, and let's go ahead and choose products and see what comes out. Now, as I remember, products kind of runs slowly when it's talking to the database because of so many items. But here we got the right things. So we've got tacos and flowers and an energy bar, and it looks to me like we've got food here instead of the other products. So in one line of code in the configuration, we have done the dependency switch. So I'm just going to go back and do one more cleanup. I've got these 2 items that are commented out. You could optionally delete those. And now we have something else that is more running with dependency. So just to make things more clear to other programmers that might be maintaining this program, I'm going to put a note that says use dependency injection, see startup CS to see the data source for repository. And really we've got ourselves a very flexible thing now. So why would you want to have 2 different data sources? Well, think about how you would run your program in a development environment. Sometimes you want to do testing, and sometimes you want to have it in production. So if you're trying to update or delete records in a production database, that's a bad idea. In this case, we'd probably just want to switch to a test database where it doesn't matter if we wreck the data or not. And so with one line in the config, we can swap out 2 different data sources. So there's an example of dependency injection in more of a real-world situation. So just to recap why we were doing this, remember that dependency injection is this programming technique to make classes more independent of each other. Hopefully you can see the independence now. Classes are more reusable, they're more testable, less rigid, and they are going to pretty much have this one feature where we're using interfaces to pass along types of items in our constructors. And so in the case here, we could swap out the wheels of a car using an interface rather than a hard-coded value. So just remember the one final rule here, that when you're writing a definition for a class, don't instantiate anything inside of it. Think of dependency injection as a better design pattern that will be more flexible for you in the long run. So thanks for watching. This was a long video on dependency injection, and I appreciate you sticking with me here to the end. We're going to move on and do some more things with caching and ASP.NET in just a moment.